Welcome folks again to our today's lesson. Here is an example under relative density in liquids. I had promised you that in our next lesson we'll be looking at one question so that I make sure at least you're following, you are getting something. So today I'm going to look at an example which is based on the relative density of a liquid. And before we go into the working, I would like to remind ourselves the formulas that can be used to calculate for the value of relative density. So in our last lesson, in our previous lesson, we looked at various equations, various expressions in which we can use to find the value of relative densities. Maybe expression number one, talking of the densities now, we say that relative density can be given by taking the density of the liquid displaced divided by the density of water displaced. Talking of mass, relative density can be given by taking the mass of liquid displaced divided by mass of water displaced. We went further and said that relative density can also be expressed in weights. In weights, relative density equals to weight of liquid displaced divided by weight of water displaced. And finally, in terms of upthrust, relative density can be expressed as upthrust in liquid divided by upthrust in water. So, the variables which are given in the question will determine what expression we will use. For our case, we have the weights, and we can use the weights to find upthrust. So, this expression suits our question very well. We are going to use this expression to calculate for the value of relative density. Why are we eliminating this one? Because we have not been given the densities in our question. Masses, we don't have the masses in our question. Weight, also it is not possible to find the weight of the liquid and weight of the water using the values we've been given. Good. Let us go straight to the business and do the working. So relative density equals to upthrust in liquids divided by upthrust in water. And for our case, the liquid we have in question is the oil. So let's call it the oil. So oil is our liquid. Good. Let us find upthrust in the oil. How do we find upthrust in the oil? How do we find upthrust in the oil? We have in our experiment with a metal cube, the following results were obtained. So we have weight of the cube in air. Weight of the cube in air. We also have weight of the cube when completely immersed in water. So upthrust is given by taking the real weight, that is the weight of an object in air, minus weight of the object when immersed in a fluid. So for our case, weight of the cube when in air is 0.5 Newton. Minus, this is our real weight. Now, the weight of the object when immersed in a fluid is known as the apparent weight. So for our case, we are on oil. So when the object is immersed in oil, its apparent weight becomes what? 0.46. 0.46 Newton. 0.46 Newton. So this is our real weight. This is the apparent weight. Weight recorded when a body is immersed in a fluid. Good. So what do we get? What we get? 0.5 minus 0.46 tunapata nini? 0.04 Newton. So this is our upthrust in oil. The next thing, let us get upthrust in water. Upthrust in water, still we are using the same procedure. Take the weight of the cube when in air, subtract the weight of the same cube when immersed in water. So weight of the cube in air is 0.5 Newton minus the apparent weight. Its weight when immersed in water is 0.44 Newton. So this gives us what? 0.06 Newton. So we have our upthrust in oil as 0.04 and also upthrust in water as 0.06. Now let us insert this in our formula, which is given by upthrust in oil divided by upthrust in water. So relative density of oil equals to upthrust in oil, which is 0.04 divided by upthrust in water, which is 0.06 Newton. So Newton cancels Newton. Relative density is a ratio, so it is unitless. It does not have units. Good. So relative density of oil becomes, that is 0.04 divided by 0.06. Folks, let us press this in our calculators and give our appropriate answer. Thank you for watching. Kindly subscribe.